Students, today we are going to discuss the topic is capacitance of a three-phase overhead line. In previous class we have discussed in single-phase overhead line. Today we are going to see the topic is three-phase overhead line. So we are going to consider three types of conductors. One is A, B, C. Okay, it carrying charges QA, QB and QC. It's separated per meter length. Okay, the distance is D. Okay, we are going to calculate the total potential difference values. Okay, so we are going to consider the integration value for A conductor, B conductor and C conductors like that. First A conductor having the integration value of R to infinite, and the charge value is QA divided by 2 pi x into epsilon naught into dx. And then B conductor have distance D to infinite, the charge value is QB, and then it have producing the electric field intensity is 2 pi x epsilon naught into dx. After that, for conductor C, having the integration limit D to infinite, and then charge value is QC, and then electric field intensity value is 2 pi x into epsilon naught into dx. These three conductors is going to be consider air medium placed in air medium. So epsilon naught our value is default, we can going to substitute epsilon naught value is 1 here. Okay, so we are going to take the common values in outside of the equation. 1 by 2 pi epsilon naught is common for all, so we are going to get this outside. After that, the charge value is represented by integration limits. QA is equal to log E 1 by R and QB is equal QB log E 1 by D plus QC log E 1 by D. These are all the charge values and the limit values for these conductors. After that, we are going to simplify these equations. For the example, infinite values are going to be get 0. So that value is neglected in this equation. So we are going to simplify these two equations because these two values, because it have common value of distance D, that means conductor B and C. So we are going to simplify, that means added this value QB and QC with respect to log E 1 by D. Okay, after that QA, QB, QC value is going to be 0 because of this equipotential surface concept. So the QA value is going to be right side, means QB plus QC value is here, na? So we are going to substitute the minus QA value into this equation. After that, we are going to get the answer is QA is common for these parameters. So the final value is QA divided by 2 pi epsilon naught. The value of this value is log E 1 by R minus log E 1 by D. In logarithmic rules, the positive value is going to be right in numerator and negative value is going to be right in denominator. So the final value of the potential difference VA is QA divided by 2 pi epsilon naught into log E D by R volts. Okay, so next we are going to calculate the capacitance value of three-phase overhead line. The capacitance of three-phase overhead line is charge by potential difference. That is the basic formula of capacitance. The charge of the conductor A is QA. After that, the potential difference in this previous equation, we got the answer is QA divided by 2 pi epsilon naught log E D by R. So we are going to simplify these equations, means QA is cancelled. This value is going to be numerator and then log E D by R in denominator. So the final value of the capacitance in three-phase overhead line is 2 pi epsilon naught divided by log E D by R Faraday per meter. Next we are going to discuss the topic is capacitance of three-phase overhead line for unsymmetrical lines. In previous slide we are discussed in symmetrical spacing. In this section we are going to discuss the unsymmetrical spacing. For the example, we are going to consider A conductor like that, B conductor like that, C conductor is placing upper side. The distance of the A to C conductor value is D2, A to B is D3 and B to C is D1. So we are going to substitute the limits D1, D2, D3 for various conductors. That means AB, BC, CA like that. The total value of the charge is going to be 0 in symmetrical and unsymmetrical conditions also. Okay. So first position. In that inductance equations we consider the number for the unsymmetrical lines. So that concept is used here. First line, second line and then third line. So first position of V1 is calculated by using 2 pi epsilon naught QA log E 1 by R, QB log E 1 by D3, QC log E 1 by D2. Okay. For V2 position, QA log E 1 by R plus QB log E 1 by D1, for QC log E 1 by D3, and then potential difference of third position V3 is equal to 1 by 2 pi epsilon naught is common for all three conductors. Okay. That after that we are going to consider the variable parameters only. So the QA value is log E 1 by R and QB is log E 1 by D2 plus QC is log E 1 by D1. The average voltage on a conductor is VA is equal to 1 by 3. That means total voltage value is V1 plus V2 plus V3. So these values is substituted in these equations, the above equations. Okay. So 1 by 3 is a common value to V1, V2, V3. So we are going to substitute the outside of the equation. After that the constant value is 1 by 2 by epsilon naught is substituted here. We are going to simplify this QA value, QB value and then QC value. So the QA value is common to all. So 1 by R is going to represent R power 3. In logarithmic equations, the base value is equal means we are going to add the power of the value. So R power 1, R power 1, R power 1 is going to be considered R power 3 here. Next we are going to simplify the common values of QB plus QC. The value is D1, D2, D3. Distance value is D1, D2, D3. In previous line we are going to calculate the QB plus QC value is Q minus QA. That value is substituted in this equation means we are going to get the value is 1 by 3 to the 6 pi epsilon naught and then QA value is log E 1 by R power 3 minus QA log E 1 divided by D1, D2, D3. Okay, this is the voltage equation of the three-phase unsymmetrical line. After that we are going to consider simplify these equations. The logarithmic value, the positive value is going to be right in numerator and then negative value is in denominator. So the concept is substituted in previous equation means we are going to get the answer is log E D1, D2, D3 divided by R power 3. Okay, so we are going to simplify this equation 1 by 3 and then QA 2 pi epsilon naught log E D1, D2, D3 means the value of the 1 by 3 is going to be right the power of the log value, going to be right the power value of the logarithmic term. So the simplified the term is QA divided by 2 pi epsilon naught and then log E D1, D2, D3 divided by R power 3 means 1 by 3, the whole power of 1 by 3. So the final value is this value QA divided by 2 pi epsilon naught log E D1, D2, D3 power 1 by 3. In this section R power 3 divided by 3 means the 3 will be cancelled. So the R is power going to be get the power value is 1. So the capacitance of the conductor neutral is CA is equal to QA by VA. So the QA value is 2 pi epsilon naught. This value is going to be right root 3 cubic root of d1, d2, d3 by R Faraday per meter. This is the final equation of three-phase unsymmetrical overhead line. Thank you.